Hello everyone, welcome to Brain Blitz Audios. Today in this episode of Bitsat Practice, we're going to be looking at previous year questions asked in Bitsat. The subject that we're dealing with will be physics and the exam is Bitsat 2018. Bitsat is the entrance examination that is to be written in order to enroll yourself into the Birla Institute of Technology and Science. So today we're going to be releasing the third part of Bitsat 2018, and the subject that we're going to be dealing with is physics. So here lies the first question of this episode. A resistor and an inductor are connected to an AC supply of 120 volts and 50 hertz. The current in the circuit is 3 amperes. If the power consumed in the circuit is 108 watts, then find the resistance in the circuit. So in this question, the RMS value of potential difference is given as 120 volts and the frequency is given as 50 hertz. Also, we know that the RMS value of current is given as 3 amperes and the average power, which is the power consumed, is equal to 108 watts. Then you need to find out the resistance in the circuit. Now, average power in terms of VRMS and IRMS is written as VRMS times IRMS times cos phi. Now, in this circuit, the circuit that we're dealing with is a circuit having an inductor as well as a resistor. So in this type of circuits, only the resistor consumes power. So therefore, the average power is equal to the power generated due to the resistor. So all it remains is to find out the value of P resistor. So the power due to the resistor is I squared times R. So here I, we can take that as IRMS. So that is 3 times R equals 108. So therefore the value of R is 108 divided by 3 square, which is 108 divided by 9. Let's do the division here. 9 goes into 10 once, minus 9 equals 1. And then there's, put the 8 down, you get 18. 9 goes into 18 twice. 18 minus 18 gives you 0. So therefore, the value of the resistance of this LR circuit is 12 ohms. 12 ohms is the correct answer to this question. And if you look at our options, you can see that option A, 12 ohms, is the correct answer. Now let's look at another question asked in Bitsat 2018. A resistor of resistance R, a capacitance of capacitance C, capacitor of capacitance C, and an inductor of inductance L are connected in parallel to an AC power source of voltage epsilon naught sine omega t. You need to find the maximum current through the resistor. The relation given is that the maximum current through the resistance is half of the maximum current through the power source. You need to find out the value of R. So you need to, the thing that you need to understand here is that the maximum current through the resistance in this type of circuit is occurring during, it occurs when you have resonance. So therefore, I times R naught is maximum current through the resistance, and maximum current through the power source will have the effect of all of the three parts, the inductor, the resistor, as well as the capacitor. So therefore that equals I times R naught, the whole square, plus I times C naught minus I times L naught, the whole squared, under root. So this is the value of maximum current through the power source. So according to the relation given, the maximum current through the resistance divided by the maximum current through the power source, I C naught minus I L naught, the whole square, put the denominator inside a root. This is equal to 1 by 2. So therefore, what we're going to do is we're going to take I as equal to E divided by Z, where Z is the reactance. So for the resistor, the reactance will be equal to the resistance of that resistor. So therefore you have E naught divided by R, the whole divided by, then you have inside the denominator, you'll have E naught divided by R, the whole square, plus E naught times C omega, the whole E naught times C omega, minus E naught divided by L omega, the whole square. That is equal to 1 divided by 2. So now what are we going to do? We're going to cross multiply this, so you get 2 E naught divided by R as equal to epsilon naught divided by R, the whole square, plus E naught C omega minus E naught by L omega, the whole square, the whole root. So now the next thing is to square both sides. So when you square both sides, the left hand side is 4 epsilon naught by R, the whole square. So 4 times epsilon naught by R, the whole square, equals epsilon naught by R, the whole square, plus epsilon naught C omega minus epsilon naught divided by L omega, the whole squared. So therefore, when you take epsilon naught by R, the whole square, to the left hand side, you get 4 minus 1, that is 3. So 3 epsilon naught divided by R whole squared equals epsilon naught C omega minus epsilon naught by L omega, the whole squared. So therefore, when you take R to the right hand side and whatever is in the right hand side to the left hand side, you get R square equals 3 epsilon naught squared divided by, we take epsilon naught squared common here, so epsilon naught squared times C omega minus 1 by L omega, the whole squared. So therefore the value of R squared becomes 3 divided by C omega minus 1 by L omega, the whole squared. So when you take the square root on both sides, you get R equals under root of 3 divided by under root of C omega minus 1 by L omega, the whole square, will be equal to C omega minus 1 by L omega. So therefore this is the value of the resistance of the resistor present in the LCR circuit. So therefore, if you were to look at our following options, you can see that option A is the correct answer to this question, and we did that by just using the relation given in the question and putting in the values for maximum current through resistance and maximum current through the power source, which is IR square minus IC minus IL, the whole squared. So putting those values, we get option A. That is the correct answer. Now let's look at this question. A direct current of 5 amperes is superimposed on an alternating current I equals 10 sine omega t flowing through the wire. You need to find out the effective value of the resulting current. So how do we start? In this question, direct current of 5 amperes is given. So the current which is DC. So direct current is given as 5 amperes, and the alternating current has the equation I naught sine omega t. So in this case, that is 10 sine omega t. So that follows that I naught, that is the mean value of current, is equal to 10 amperes. So rated current in an AC circuit is equal to IRMS, and IRMS is often written down as I naught divided by root 2. So therefore the value of IAC, that is IRMS, is equal to 10 divided by root 2 amperes. So now we know that through the direct current is 5 amperes and alternating current that is rated, so that means the RMS current passing through the AC circuit is 10 by root 2 amperes. So now we need to find out the effective current. So effective current, I effective, is the sum of the squares of IAC and IDC put under a square root. So that means it will be IAC the whole squared plus IDC the whole squared whole under root. Now IAC is 10 by root 2, that is squared, plus IDC is 5, that is also squared. So therefore you get 100 by 2 plus 25, put that under a root, you get 50 plus 25 under root, so that is 75 under root. So 75 can be written as 3 times 25, put that under a root, and you know that under root of 25 equals 5, so therefore the value of I effective is 5 root 3 amperes. So the correct answer to this question will be option B, 5 root 3 amperes. So in order to find this answer, we just found out the alternating current that is rated, which is IRMS. So IRMS is I naught divided by root 2, where I naught is already given. And then the effective current will be the sum of squares of AC and DC current, and we put that under a root in order to get the effective value. And the effective value is finally turning out to be 5 root 3 amperes, which is option B. Now let's look at this question. The electric and magnetic field associated with an EM wave propagating along the positive z-axis can be represented by. So we have the 4 options. In the 4 options, it is showing the direction of the electric field as well as the magnetic field, separated by commas for each option. Now, in this question, the EM wave, the electromagnetic wave, is passing along positive z-axis. Now we all know that the direction of an EM wave is perpendicular to both the electric field vector and the magnetic field vector. And we also know that the electric field vector is perpendicular to the magnetic field vector. So since E is perpendicular to B and the direction of the EM wave is perpendicular to both these quantities, so if the EM wave is passing through the z-axis, then the electric field and the magnetic field will be in the xy plane. Now, the direction of the EM wave will be given as the direction of E cross B. Now, one vector crossing another vector should give you an EM wave vector passing through the positive z-axis. And in vectors in mathematics, you would have studied that vector I cap cross j cap will automatically lead you to k cap. So it's written like this, ijk, and the vector multiplication goes counterclockwise for positive values, and if it goes clockwise you get the negative value as the product. So I cross j is k and j cross I is minus k. So since we have plus k, so therefore the cross product has to be between an I component and a j component. So I cross j gives you k. So therefore the electric field has to have a vector along is to be a vector along the x direction, and the magnetic field has to be a vector along the y direction. So therefore option A is the correct option. In option B, E naught is present along k, the vector k, but then that would be but then that would lead to a EM wave that is along the j axis, so that's along the y axis, so that's incorrect. And if you have option C, then this would also be incorrect because I cross I gives you 0, so there will be no EM wave in the first place. And then if you have j times k, you get I, so the EM wave would be passing along the x-axis instead of the positive z-axis, so therefore option D is also incorrect. The right answer is option A. Electric field is E naught I cap and magnetic field is B naught J cap to form an EM wave propagating along the positive z-axis. Now we've reached the final question of this episode. Two concentric conducting thin spherical shells A and B having radii RA and RB, where RB is greater than RA, are charged to, so the shell A is charged to QA and the shell B is charged to minus QB. So charge on A is positive, charge on B is negative, and it's said that the magnitude of B is greater than the magnitude of charge of A. So we need to find out the electric field along a line passing through the center. So you have a shell A and a shell B. Now I know that it's not the correct way to draw it, but then this is as close as you can get. So you have radius of A, and then you have radius of B, charge of A, charge of B. Now, in a spherical shell, the electric field E inside the shell will be equal to 0. Now the reason why is that there will be no charge enclosed inside the sphere, inside the spherical shell, as the charge is on the shell. So therefore, for R less than RA, the electric field will be K times 0 squared divided by R. So therefore, you would have electric field as equal to 0. So this is the first case. Now, what happens if you have R greater than RA, but it's less than RB? So let's say if this was the radius that was given to us. So in this radius, the charge is enclosed. The enclosed charge will be the charge on the spherical shell A. So therefore, you would have E equals K times QA squared divided by R. So therefore, the electric field here is inversely proportional to R. And in the first case, E is equal to 0. And then for the radius that are always greater than RB, the electric field will now be equal to K times minus QB plus QA the whole square divided by R. So therefore, the potential here is negative, and it's also inversely proportional to R. So the electric field is negative and inversely proportional to R. So therefore, the correct graph that can represent all of this is option A. So in option A, you can see that from 0 to RA, there is nothing. There is no electric field, since the electric field is 0, so there is no line. And then from here onwards, it's E proportional to 1 by R. And then from RB to infinity, you have E proportional to 1 by R, but it's also negative. So the negative of that inverse proportion is being followed here. So therefore, option A is the correct option. Now, this graph is correct for the electric field. If, for example, you had electric potential, then for the electric potential, you would have a constant potential inside the shell. So therefore, option C would have been the correct option if it was potential. But the question here specified electric field. So option C is incorrect. Option B is incorrect because it does not, because the part that is between RA and RB is incorrect. And also option D has the wrong graph from 0 to RB. That is also incorrect. So therefore, the correct graph here shown is option A. Now that concludes this episode of Bitsat Practice. We hope you found this episode interesting. For more of our useful and interesting content, don't forget to subscribe to our channel, which is Brain Blitz Audios. We also have a playlist which contains all of the questions that we've discussed about Bitsat. If you want to access it, you can always hit the link for the playlist in the description box down below. To receive the latest updates from our channel, don't forget to hit that notification button, which is present below the video. So until the next webisode, take care, stay safe, bye-bye for now.